All right. Hi, guys. Welcome to our last week of physical geology. Sad face. This week we're going to talk about glaciers and climate change over geologic time. So I'm going to introduce you guys to what a glacier is first, and I'll segment this into pieces and parts too, just to make it a little bit easier for you to understand. So a glacier, in simple terms, is just a sheet or a mass of moving ice. And this is something that forms over hundreds, if not thousands of years due to seasonal snowfall and then accumulation, compaction of those layers, and then recrystallization of the snow into ice. And of course, like water, ice responds to gravity. And so understanding how glaciers move, glacial mechanics, has everything to do with understanding topography and also gravity, the response of this ice to gravity. And so we can subdivide glaciers into two basic types. There are something called a valley or an alpine glacier. And these are glaciers that exist in mountainous areas. So some of the ones that you might be familiar with would include like the Rocky Mountains in the west, the Cascade Mountains in the Pacific Northwest. Alaska has a lot of valley or alpine glaciers. The Himalayas. So all of the world's largest mountains with the highest elevations have these glaciers. And again, these will flow in response to gravity from the head, which is closer to the peaks of these mountains, towards the valleys below them. So the other type of glacier is something we call an ice sheet. Now, ice sheets are massive, meaning that they cover a much larger surface area than a valley or alpine glacier. And so we have ice sheets on Earth in two places. One that covers quite a bit of land in Greenland, despite its name, and the other is in Antarctica. And Antarctica is a really complicated place in that it both has land ice and sea ice. And so what I'm going to do is a couple YouTube videos that talk about the difference between those two types of ice sheets, one flowing over water, one over land, and then kind of relate that to climate change through time. So here's a picture of a valley glacier. And contrary to what you might think, these glaciers actually appear really dirty. They are not only moving in response to gravity, but they're also eroding the landscape. And so they're picking up a lot of sediment and pulverizing rock underneath. And as a result, you tend to see these kind of lineations of black on white that represent all of the sediment load that's carried with that glacier. And then here are our ice sheets. Again, I'll get into more detail, especially with Antarctica later this week. But there's one near the North Pole in Greenland, one near the South Pole, all of Antarctica. The ice that covers the North Pole, contrary to Greenland and Antarctica, is sea ice. And so when we talk about climate change, there's a difference in land versus sea ice. And we'll get into that later this week as well. All right, so the most recent ice age ended approximately 12,000 years ago in Ohio. And during that time, it was about 2 million years to 12,000 years ago, there were vast areas of our world that were covered with these ice sheets, including kind of the northernmost extent of North America, all of Canada, and all the way down into Ohio. About 2/3 of Ohio was covered with an ice sheet during that time. And that was our last glacial maximum. So that was the last period of time where the planet was cool enough that we had significant accumulation of snow and then compaction and ice, obviously. And over that time, of approximately 2 million, although they say about 2.5 million years here, there were periods of glacial advance where the glaciers would move forward, accumulating more ice. And then there were times of glacial retreat where the glaciers would do just the opposite. So periods where you had less snowfall or the climate was slightly warmer. But regardless, that was the end of the last ice age. And so we are now in what's called an interglacial period. That's not to say that we won't have another glacial period on Earth, but right now we're in a period of significant warming. Some might say, including me, that it's anthropogenic in that humans have had an effect on the rate of this warming. All right, so today's ice sheets obviously cover just part of our planet in Greenland and Antarctica. Like I said, the Arctic Ocean is covered primarily with sea ice, which is frozen seawater. And it is not glacial in the extent that we think about it. Sea ice can be meters thick, whereas land ice or glaciers can be thousands of meters, if not miles thick. Sea ice will expand during the colder months, meaning it kind of grows in area, surface area in the Arctic. And then over time in the summer months, it shrinks. Some climatologists estimate that by 2050 or so, the Arctic will be free of sea ice during the summer months. So that's pretty significant. Glaciers that form on land are called continental ice sheets. And again, Greenland and Antarctica are the two that we know of. There are a few smaller ones in Europe, but these are the big guys. And Antarctica is by far and away more ice volume than Greenland. And what's interesting about both locations is there's a really complicated mechanism by which these ice sheets flow and move, again, in response to gravity. So we'll get into that here in a little bit. Speaking of gravity, when ice moves over the oceans, it can create kind of an ice shelf. And so when we look at Antarctica, there's really two components to the ice here. There's ice over land, and then there's ice over water. And when ice moves over water, it becomes a little bit more complicated in that there's some heating of the ice from underneath. And so as the oceans become warmer, we're seeing more instability in these ice shelves, and they're starting to break apart, which obviously is concerning because when they break apart from land, they enter the ocean and then eventually melt and cause a change in sea level as a result. And we're seeing that happening at an accelerated rate in the South Pole. So here's kind of what it looks like. You can see here's where kind of the land stops, and then obviously the ice is moving out and over the ocean, and here there's kind of an accelerated rate of melting where the ice is thinning, and then eventually that ice breaks and you get icebergs or floating pieces of ice that are kind of rafting out into the ocean. So here's what that looks like. Here's the ice shelf in Antarctica. This was back in 2002. You can find more recent occurrences of this if you Google, but here's ice breaking up in Antarctica back in January 2002, and then you have icebergs kind of rafting out over the ocean. I'm not going to go into these other types of glaciers so much since we only have a limited amount of time, but this is kind of a cool one. In Iceland, again, the name says that it's icy, but really there's not a whole lot of ice other than what's on kind of the mountainous volcanic areas of the island. But this Vatnajökull ice cap is kind of cool. We've been here, and if I think about it, I'll try to show you guys some pictures of that. But you can see here, this is a pretty big ice cap, and you can see where the ice is extending out as meltwater actually into the Atlantic here. But you have all these little glaciers. They're almost like little fingers. It's kind of got a weird dendritic pattern that feed off your main glacier. Kind of looks like this, where the glacier spreads out. This is called a Piedmont glacier, and you see a lot of these in Alaska. I'm going to go ahead and stop here, and then I'll start up the next segment of this video talking about how glaciers form and then how glaciers move, which is really complicated, similar to water, but obviously different because we're talking about solid ice as opposed to liquid water. So stay tuned.